Hello, welcome to GCC's Math 103. I think this is 103, right? Maybe 104, whatevs. We'll be covering chapter 5 today, factoring. Factoring is, of course, a very important tool to have in your math arsenal. And I don't know why the book decided to wait at this point to discuss it, because we kind of factored before now too, but hey, whatever, we're getting there finally. So let us begin. We'll start out with our common factors and factoring from polynomials. So again, we discussed this when we talked about polynomials and variable equations. When I was talking about clumping together like terms, that's basically factoring. And we can look here, 6x to the third y. We can clump that into like terms. Fantastic. 8x squared y squared, we can clump that in like terms, put our x's together, put our y's together, again, fantastic. But if we have multiple equations and multiple variables, we can see what's common between them. Because if we know what's common between them, we can use that information to make math easier, essentially. We notice here 6x to the third y, when we break it down into its factors, including chopping that 6 up into a 2 and a 3, because 2 times 3 equals 6, right? We notice that there are terms shared with the lower equation, 8x squared y squared. Namely, both of those need 2 x's, both of those need at least 1 y, and both of those share at least 1 2. Those are highlighted in blue there to create a greatest common factor. The other stuff is what makes it unique. So if you start with a 2 x's, and a y, and you multiply that by 3x, you get 6x cubed y. Or if you multiply that by 2 and 2 and a y, you get 8x squared y squared. So that greatest common factor, this dude here at the bottom, that is the smallest variable, the smallest term, the smallest equation that derives out both of these options. So that is a greatest common factor. Here's more examples. Again, we will see the use of this as we continue going on. But it's important to understand where this is and how it gets out. Again, pause if you want to take a deeper dive into this. Once we start doing the actual work in the chapters, we'll have it there. Oh, wait, what just happened? Oh, that was weird. Okay. Polynomials essentially work the same way. They are taking the different terms in the polynomial, pulling out what's important, leaving the rest. Here we have 2x squared, which chops down to 2 times x, and 10x, which will go into 2 times 5 times x. So both have a 2 and both have an x in common, which means I can pull a 2 and x out of both of them, resulting in, follow the blue arrows, 2x times x plus 5, because x and 5 are the remaining things. I think we talked about this before, but just to emphasize it now, when we're factoring the equations, we're factoring down into prime numbers. We can get larger, for example, 20, right? 20 goes into 2 and 10, but since 10 is not a prime number, that means it can be factored again, namely into 2 and 5, right? So 2 times 5 is the prime factorization of 20, not 2 and 10, because 10 still breaks down more. Here's some examples to get at. Again, I want you to do this stuff. So when you look at 5x cubed minus 5x squared plus 10x, the prime factor, the greatest common factor, or the prime factorization of that, is what term or what combination of constants and variables, letters and numbers, apply to every single one of them. Because if you can apply the same constant to all of it, you can make your equation simpler. Notice here, our greatest common factor is 5x, because 5x is a part of each of those three terms. That's useful because if I essentially pull 5x out of it, as shown here, I can create a new equation that has much more simple terms and a much smaller numbers. This equation down here at the bottom, this dude, is the previous equation, this guy up here, but I factor out the 5x, so I kind of remove it, right? So I have a more simple equation, x squared minus 7x plus 2, right here, that is essentially the same thing as this big ugly equation at the top, but I know that 5x is a part of the entire thing. And we're essentially writing equations in a more easy to understand, more simple way in order to be able to do math to them without having to worry about big numbers like 35. So that all being said, here's a chance for you to practice. What are the factors of 8x squared plus 2xy, the greatest common factor? Or what is the smallest amount of stuff that's in both of them? So pause the video. All right, you back? The answer is 2x. How did it get there? Well, so 8x squared. I'm going to break this down big. What does 8 break down into? Well, 8 breaks down into 2 times 4, right? And x squared, well, that's x times x. So that's done. Well, 2 is a prime number, 4 is not, because 4 goes into 2 times 2. And what I'm doing here is I'm kind of making like a Christmas tree of the factorization. I definitely promote that. I mean, I've been doing math for years now, and I still make a Christmas tree out of my factors because it just helps simplify the thing. You can do whatever you want that's effective to you. This is what I suggest in these Christmas trees. 2xy, well, nothing really breaks down because 2 is just 2. X is just x, and y is just y. So we look at our strings here, 2 times 2 times 2 times x times x. Over here we have 2 times x times y, and we find what's similar among them. Well, they both have a 2, right? This one over here on the left has 3 2's in it, but the one on the right does not have 3 2's, it has 1 2. So we only highlight that 1 2 because that's what's shared between them. The second 2 is not shared in the second equation, so I don't care about it. I notice we have an x, and that's it. So 2x is our greatest common factor. Both equations have a 2x in them and nothing larger. Of course, this is useful because we can extract 2x out and essentially get a easier equation with smaller numbers and less extra bits to it, right? We pulled an x out of both, so I don't have to worry about x's all over the place. Here we have factoring by grouping. This is for doing binomial factoring, and it's a lot of kind of more of the same, right? We discussed this when we discussed the properties of addition and subtraction in previous chapters, but the equation on the left here and the equation on the right here are the same equation. One is pre-distribution, one is post-distribution. And we can essentially continue that through, and we've been carrying our negative numbers throughout and distributing them. We've been factoring by groups. Now you just know the fancy word for it. Congratulations, you should be very proud. Again, this is kind of best done by doing. So I'm going to highly suggest we do that. Pause, take a go at this. If you get lost, run the video again. Cool. So how do we factor 9x squared minus 15x minus 6xy minus 10 plus 10y? There's a lot going on there. I will tell you all 4 of those don't share any particular letter, right? The second 2 have the last 2 have a y, and the first 3 have an x, but no letter is shared among all 4 terms. So I can't easily just pull a letter out. Likewise, not everything shares a number, right? Because 9 is 3 and 3, 15 is 3 and 5, 6 is 2 and 3, and 10 is 2 and 5. So these four terms do not all share a single number. Again, problem, right? So I can't just use the tools I've been using in the past. I have to do something else. Well, that's where factoring by grouping comes in. First suggestion here is try to figure out exactly what's going on with your pluses and your minuses. I have a minus 6y on the front there. What do I do about that? Well, one suggestion is to distribute out the negative. Or as shown here, if I swap this positive 10 for a negative 10, I can then pull a negative out of the entire last two equations here, right? I can pull a negative out of both of these. This negative goes out in front, and this plus turns into a negative because I subtracted the negative out and put it right here. Essentially, we have less to worry about as we play. So as I continue, I can now find factors in smaller amounts. For example, I can pull a 3x out of the ones in the front. I can pull a 2y out of the ones in the back. Lo and behold, when I do that, I have a shared common factor of 3x minus 5. So there we go. I have my group factor by grouping. This isn't going to work always. You have to have the equation built so that it can be group factored. A lot of that you'll see in this chapter do that because we're teaching you the process. Don't always expect this to happen though, right? This is a consequence of that sort of factoring. And again, this end result is simply this, when you distribute it, becomes that, right? All right, so let's continue factoring. Let's go into the classic x squared plus bx plus c form. Or here as x squared plus bx plus c, same difference. X squared plus bx plus c is where this is just a equals 1. Going off topic, sorry. So if we have the trinomial form of x squared plus bx plus c, we have kind of hints and tricks and fun little tidbits going around there. First of all, when you see something as x squared and x and then no x, right? That's a very common form of an equation. So common, in fact, that again, we label the second letter B and the third letter C. Sorry, the second constant B and the third constant C. Technically, there's an A there too. We'll get to that. So for all these different equations, we can have a B and a C, right? And how that is useful is, first of all, it allows for easy factoring by grouping. Because once I know what B and C are, I can separate them out and get very easy factoring. X squared plus 8x plus 12 factors into x plus 6, x plus 2, because B is because I know B is 8 and C is 12. How did that come about? Let's show you right here. Signs and factoring. So essentially, what you need to do is care about the sums of the letters and the products of the letters, because when you, we're gonna do this a couple of times, and then you're gonna kind of get what's going on here. Once you know B and C, you need to figure out what two things add up to B, and then what of those same two things, if I multiply them together, get C. Because if I can figure that out, that's the answer to my question. So here I have an 8. So what adds up to 8? And again, we can go over this more details. I'm just giving you the quick last. What things add up to 8? 1 plus 7 is 8. My gosh, that is completely ugly. Let's just type that. There we go. 1 plus 7 is 8. 2 plus 6 is 8. 3 plus 5 is 8. And 4 plus 4 is 8, right? Fantastic. Now, what numbers multiply to form 12? Well, 12 is formed from 1 times 12. 12 is formed from 2 times 6. And 12 is formed from, what, 3 times 4, I think, right? Yeah, 4A 12, yeah, cool. So, on the left here, I have the things that add up to B. On the right, I have things that multiply out to C. Are there any shared numbers between them? Yes. These two are shared. If I have a 2 and a 6, I can add them to form 8. I can multiply them to form 12. Then I'm done. I have successfully found my grouping pairs. All right, so that was a quick little short blurb. Now let's go step by step by step. So when factoring the form, the equation of the form x squared plus bx plus c is important to, I'm just going to read this out to you. It's important to notice relationships that allow easier factoring, essentially easier solving of the problem. First thing is, when the constant term of the trinomial is positive, the constant terms of the binomial have the same sign. Meaning, here we have x squared plus 8x plus 12 at the top here. Since both of these are positive, these two are also positive. When they are both positive and the coefficients of the x term and the trinomial is positive, they are both negative and the coefficient of the x term and the trinomial is negative. What does that mean? Well, here, if b is negative, by definition, both of these need to be negative. Because remember, we're adding things together to form B. You can only add numbers together to get a negative number if they're both negative. Really, right? Or if they're positive, but we'll get to that. But if you multiply two negative numbers together, you get a positive number. And the C variable here is a positive number. So how do you add to get negative and subtract and multiply to get a positive? If you have two negative numbers. If both of these dudes are negative, as shown here, when the constant term of the trinomial is negative, the constant term of the binomial is opposite signs, but when they're the same, then you have fun this way, because how do you multiply to get a negative number? You need to have at least one negative number, right? But you also need to add them to get a negative number. So yeah, kind of play some fun little switcheroo games on you. This is all probably sounding a bit much. It sounds a bit ridiculous. This is, again, practice makes perfect. You learn math best by doing. When you run through these 4 or 5 of them, you're gonna, when it clicks with you, it's gonna click and it's gonna be cool. It's gonna be kind of fun for a bit, not gonna lie. So keeping those terms in mind, let's go through some factoring processes here. Here we have x squared minus 7x plus 10. How can I factor this into groups or into two sets of parentheses that I can more easily manipulate? And actually, the next chapter will show you why we do this, because of the ease of manipulation. So what are the negative factors of that I can add together to make -7, and I can multiply it together to make +10? In this case, the factors when I figure this all out, are -2 and -5 add up to -7, and -2 times -5 add up to +10. How did I get this? Well, again, it's not showing you, which it would, but what two things add up to 7? So what two things add up to B, and then what two things multiply together to form C? So add up to -7. Well, again, without going into ridiculous quantities, right? I know I have, and since again they're swapped, both things are negative, right? We talked about that already. So -1 minus 6 would give me -7, -2 minus 5, and -3 minus 4, right? Essentially. So I have those for the B, and then for the C, I have negative numbers that multiply together to form +10. So that's going to be -1 times -10. Oops, let me swap that. -1 and -10 will do it. I also have -2 times -5 will do it. Oh, I can just stop right there, because I have a -2 and -5 in both, therefore they're my factors. That's therefore what I need to succeed. And that's exactly kind of what's going on here. Let me clear that drawing, that looks gross. All right. Again, when we factor this out and make it big Y's, as shown down here, we see this stuff go through. Again, this is really all about practicing and running it through and checking stuff. So how do we factor x squared minus 8x plus 15? First things first, I need two things that add to a negative but multiply to a positive. That's two negative numbers. So I know right off the bat my numbers are negative. That being said, go through the factors that add up to -8 if both numbers are negative. And then once you get a decent list, start going through the factors two negative factors that multiply to make -15. Once you find something that lands both places, you have it. Pause the video, by the way, in case you didn't already. Okay. So there's some factors that can get there. In this case, -3, -5 are what we are looking for. -3 plus -5 is equal to -8. And -3 times -5 is positive 15. Therefore, those are my factors. You can combine all these different steps to really break down big equations, as shown here. This is, again, just going through the process. Something I'm always going to suggest, especially when we get to these points, use a lot of paper. Don't try to squish everything. I'm not giving you bonus points for using less paper. That's pointless. Don't do that. Use as much paper as you need to properly solve the equations. And if you don't know, if you did it correctly, reverse the process. Make sure you get your original equation back. Again, have a go at it. In this example, we can actually subtract. This is interesting. We can pull a -3 out of everything. I know you probably wonder, how do you pull a -3 out of everything? Well, I'm sorry about the screwiness of this, of what's going on here. But you can always, when you pull a negative out of something, you're essentially switching all the signs, right? So I can pull a negative out of this, like this, which turns that first sign to positive and turns the other two signs into negative. Now I can look at this and I can pull out more things, such as the 3, right? Because 3, 9, and 12 all have a common factor of a 3. So if I pull a 3 out of a 3, I just get, nothing. X squared. Pull a 3 out of a 9, I'm left with a 3. Oh, these are cubed. I missed that. Sorry. It's so ugly. And then if I pull a 3 out of a 12, I get a 4. I also notice there's x in common. X squared minus 3x minus 4. And now I have that familiar x squared plus bx plus c mode that allows me to do the factoring I did prior. You may wonder, why can't I just pull the positive 3x out? If you pull the positive 3x out, you're left with a negative number at the start, which kind of screws up that negative in front of the x squared, breaks the easy format we were using. The rules we were using for the x squared plus bx plus c break if there's a negative in the front. So that's why I pulled the negative out to begin with. You don't want that. Otherwise, you can't use the simple rule. And go through and factor it, and there you go. There's your answer. Cool. So that's x squared plus bx plus c. What if you do have something in front of the x squared? Well, the rules alter a little bit more difficult, but still very doable. In fact, I would say the majority of the time that if you do something that involves a lot of factoring, you're probably actually going to remember these rules instead of trying to get the a out of there, turn the a into 1. Cool. So, as I said before, if we, instead of the form x squared plus bx plus c, if we put a constant in front of the x squared, such as a -1 or a number here, 3 or a 6, whatever, we have the same conversation, it's just a bit more difficult, right? Look at these rules. So, to reduce the number of trial factors, you must consider the following. Trial factors are running down all the things that add up to B, running down all the things that multiply to C, right? Those are trial factors. And you can keep going until you find it, but there's a certain point where it's obvious to stop. And that's what these rules are about. So use signs of the constant term and the coefficient of x in the trinomial to determine the signs of the binomial factor. We talked about that before, right? If the constant term is positive, the signs of the binomial factor would be the same as the sign of the coefficient of x in the trinomial. If the constant term is negative, the constants will have opposite signs. Yes, we talked about that already. If the terms of the trinomial do not have a common factor, then the terms of the binomial factor will also not have a common factor. That's essentially saying this ain't always going to work. You're going to find situations where you can't group factor it out. Cool. So what's going on here? 2x squared minus 7x plus 3. No common factor, right? 2, 7, and 3 are all prime. You can't pull anything out of them. But you do have that the constant term is positive and the coefficient of x is negative. Meaning the 3 is positive and the 7 is negative. So you need to have two negative numbers in the binomial grouping, since they need to add to a negative number but multiply to a positive number. So let's take a look at the different sides and see if we can find something that works. Again, this is kind of fun at this point because I need to also care about that 2, that a factor. I need to somehow create that binomial grouping. Remember, the binomial grouping is those two parentheses multiplied by each other. And we haven't quite gotten into this yet. Again, I'm not a big fan of how the book organizes this chapter, but what's going on here is these two first places need to multiply together to create your first term, right? So this and this multiply together to again form 2x squared, right? In the previous ones, these are both x's, so I always got an x squared. But how do you get a 2x squared via multiplication? And then what do you do from there? Well, again, I wish they would say this beforehand, but it's called the FOIL method. FOIL. This stands for first, outside, inside, last. Again, this is like PEMDAS, where you should probably write this on top of your homework every time you do polynomials and grouping and factoring until it becomes memorized. The FOIL is first, outside, inside, last. That's the organization of how the binomials are multiplied together to get your equation at the end. And it also gives you a hint as to the organization of your pairs of parentheses, right? The firsts go in, you multiply the first of each at the start because that gives you your first. Your outside is going to be, let's use a different color here. Your outside is going to be these, here, and your inside is going to be these, inside, and then last, let's do, I guess, yellow here, last, right there. And the last term gives you the last term here. And the outside of the inside, those need to add together to this. So the difference between what we just covered and now is FOIL. Because you didn't really need to care about FOIL, because I said you need to find two terms that add together for B. The O and the I of FOIL need to add together to B. And then the last needs to multiply together for C. If that's a lot, if you're like, the heck are you talking about? Practice makes perfect. We'll give you lots of work through examples. That's how this needs to work. And the other fun part about the other fun part about this process is you don't know if you're right until you actually do it, because there's gonna be multiple answers that look right in your head, but don't pan out when you do the equation. Which is exactly what we're looking at here. Technically, 1 and 3 are what you need to get +3, right? You have -1 and -3. But which is which? Because you could do x minus 1 times 2x minus 3, or you could do x minus 3 and 2x minus 1. One of those works, one of those does not. So you just need to run through both to figure out which one is the answer. In this case, the answer shown here in blue. So how do we factor this dude? 3x squared plus x minus 2. First of all, I have a positive b and a negative c. What does that mean? I need something that adds up to positive, but multiplies to negative. So I need to have in my binomial, right? So this is the stuff I would be drawing on the paper as I'm looking at this. I know that what I was doing yellow. I know I'm going to have a binomial because it's ax squared plus bx plus c form. And I'm going to have a positive and a negative. But I don't know if it's going to be like this or like this, right? Because both of those have a positive and a negative. Cool, I got to figure that out. But I know that's the step so far. For my A, I have a 1 and a 3. Right? And then for my 1 and my 2, I have a bunch of 1s and 2s, right? I can factor out my first and I can factor out my last. So I know my first part needs to have a 1 and a 3, but again, where? And the last part of my binomial needs to be 1s and 2s, again though, where? So how do you solve this? Eventually, you're going to figure out little hints and clues, and mental math tell you what works and what doesn't. At this stage, you are writing everything down and running through it until you get something that hits. I know it sounds terrible. That's what you got to do, though. That's how you learn this stuff. So as shown here, we have our trial factors written down, and then we run through everything. We FOIL it, because for each of these first, they're all going to give us 3x squared, right? And for each of these last, they're all going to give us -2. But the outside inside, the middle part of FOIL, that's the term where the things need to add together to create +1. And if we look down here as these bottom examples, so outside would be x times -1, which is -x. Inside's 2 times 3x, which is 6x. -x plus 6x is 5x. This doesn't work because 5x is not x. And then we can run through here. So outside x times 2 is 2x. Inside -1 times 3 is -3x. That gives us a -x. Nope. Outside x times 1 is x. Inside -2 times 3x, -6x, -5x. No. Okay, let's try this one. Outside x times 2x is -2x. Inside 1 times 3x is +3x. -2 plus 3 is +x. Ding, 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 ding. We have a winner. Those are the factors of the variable equation 3x squared plus x minus 2. And until you get the mental math down to kind of shortcut this process, you're going to need to write it out until you find it. And that's good. That's good practice. That's how you do this. That's how you learn math. If you're looking for the quick solution of these things, you're not learning math, you're learning calculator. And calculator only gets you so far, right? If you're my nurse, I want you to know how to do some math when you're calculating my dosages. Here we have grouping form. Again, I'm giving you multiple different tools to use to solve this. I kind of like the brute force method that we showed before. Grouping, however, is very good as well. So essentially, it's kind of a reorganization of what we just said. To factor the form ax squared plus bx plus c, first find two factors of a and c whose sum is b. Then use factoring by grouping to write the factorization of the trinomial. What do I mean by that? Well, for the equation 2x squared plus 13x plus 5, we can find two positive factors of 30, in this case 2 and 15, right? Whose sum is 13. So I take 2 and 15, multiply them together, to get 30. And then what factors of 30 add to form 15? Sorry, add to form a middle one, which is 13. Well, 1 times 30 gives me 30, but that doesn't add to 15. 2 and 15 multiply 30, but that doesn't add to 15. 3 and 10 multiply 30, and they add to 15. So 3 and 10 are my factors. And then since I know my inside factor, I can then figure out my outside factor by essentially extracting out the stuff I don't care about. So I break down my original equation with my pencil. I prefer math in person. This works a lot better on a whiteboard, right? I take my original equation here, and I know I need to break down 13 into 3 and 10. So I rewrite my equation, breaking it down. Then, since I've broken down my b constant, my center variable, into its components, I essentially have my FOIL written out for me long ways. I'm kind of doing FOIL backwards here, right? Because I have my first, my outside, my inside, and my last completed. So when I pull those out, I can then rewrite my long equation and FOIL backwards to get what I want. See here, you throw the parentheses around, and what can you extract out of both? Well, you can extract an X out of here. You can extract a 5 out of this dude, right? So I have an X and a 5, and I have an X and a 5, and there we go. And I can refoil it, which is what's shown here, right? First, outside, inside, last, and get my original equation. Practice, practice, practice. You're going to need to do both. Go back to these slides, go back to the book for reminders. Once you get it, and once it makes sense, it's pretty sweet how these things come together. So again, what do I do here? Well, I need to find factors that multiply together. So I need to multiply A and C. So 2 times negative 10 is negative 20. And then what factors of negative 20 will add to positive 19? So I can run through all my factors from negative 20 until I hit 1 and negative 20. 1 and negative 20 add up to 19. So I know negative 1 and 20 are my inside factors, my outside and inside of my FOIL. I can write out my FOIL equation here, insert my parentheses, and then extract out the common factor of each thing in parentheses. Over here, I have looks like I have an X, and over here I have, looks to be a 10. Cool. Now reorganize what I've written into 2 binomials, since this 2x minus 1, 2x minus 1 are the same. Solved, right? You're going to want to write this stuff out by hand. You go on, look at it, think about it, all important stuff. We're going to end this slideshow on, give it a negative 20. We're going to end this slideshow on special factoring. These are tricks, essentially. If you have an equation written with a plus b, a minus b, so it's the same thing on both binomials, those factor in a squared minus b squared. It's a quick little rule. If you see it, cool. If you don't see it, you get the same answer doing it long form. So there you go. So x plus 2, x minus 2, form x squared minus 4. Cool. Again, if you see form a plus b, a minus b, or a minus b, a plus b, you can shorten it that way. Good for you, I guess. There's some reasoning. A plus b squared, or the same thing multiplied by itself, gives you the perfect square trinomial, a squared plus 2ab plus b squared. These are honestly what the book is introducing you to these concepts now. These concepts will become more important in later math when you learn their application. So at this point, I'm going to honestly suggest doing the hard work of solving this stuff. But if you realize one of these shortcuts and do your math according to that shortcut, Good for you. You saved a couple minutes. Again, here, you can factor this out, 2x squared, 2x minus 5 squared. So that it was actually in the form of a squared plus 2ab plus b squared. Cool. Again, does this look familiar from any of the tricks? If it looks familiar from the tricks, then you can very easily solve it. Otherwise, you'd have to do the long form. That's perfectly acceptable as well, of course. All right, last little bit, solving equations. This is, word problems as usual and stuff like that. I think, yeah, I think so. Remember your basics, anything times 0 is 0 and stuff like that. Okay, quadratics. I'm kind of skipping through the end here because we're going to do more in depth in the next chapter. Quadratic equation is a very famous equation that you will use a lot when you get to higher level math. Didn't even go over the quadratic equation. Whatever. When we do the quadratic equation in more depth, I'll go over it in more depth. The book kind of slacked off there. The sum of example 4, the sum of the squares of two consecutive positive even integers is equal to 0. Find the two integers. Wow, that's a lot. All right. So what's it saying? Well, if we have some positive even integer n, then a second positive integer would be n plus 2 because it's a consecutive positive even integer. So 2, 4, 6, 8, that's adding 2 each time, right? So I need to find the sum of the square of the first positive integer, and then I need to find the square of the second positive integer, have those both equal to 100. How does that work out? Well, it works like that. I square the first integer, I square the second integer, I set them equal to 100, and then I try to solve it. Just work it out. Again, so I have my n squared here, and then n plus 2 squared expands out here. That is a shortcut that we talked about at the beginning of this section. Set it in the common form of ax squared plus bx plus c. As shown there, subtract over the 100, you get a quadratic equation. Very common. Factor it out. That was easy. Cool. And that's chapter 5. So this chapter 5, the important thing about this chapter, the thing I want you to do is honestly not special factoring. If you learn these shortcuts, they're so uncommon, you're best just figuring out brute force method, right? Knowing how to write out these big equations and finding more simple solutions to them and how to manipulate equations is actually what you do in mathematics. So have fun with the chapter, and we'll see you later.